Okay, now we're going to also focus on hazards today. I want to share with you that GIS is firmly anchored in science. It's a science unto its own. It's a GI science, a location science, a science of where, if you will. But if you look at this GIS for science page, I'm going to put this in the chat box. If I have it, yeah, here we go. I'd like you to explore this. This might be on a screen in the room there for some of you students, but it might be a little hard to read. But GIS for science, just do a search on that. And there are loads of examples of GIS being used in hazards, like we'll talk about in a minute, ocean studies, biomes, ecoregions, water resources, climate, weather, etc. Okay, so there's no shortage of examples with interactive web maps that you can start exploring on your own. The other thing that I wanted to focus on here is a couple of key hazards data sets and studies that allow us to not just look at the tools, but think about the broader issues of data quality and some other aspects that I think are important going forward. How's everybody doing so far? Is everybody bored to tears? We never want to have Joseph back. This is the most boring thing ever. Hopefully not. Hopefully you're saying, oh my gosh, there are so many things. There's so many nuggets here that I can like chew on over the weekend. And then you could email Joseph and say, hey, it's Saturday night and I'm in business analyst web. Okay, cool. I'll say that's awesome. But one of the things that I wanted to share is, okay, we've got ArcGIS Online, which is a way for you to fairly easily and quickly make maps, share maps, do some spatial analysis. So I've got this tornado tracks data. It's important to know where these maps come from, where these data sets come from. So in this case, I'm seeing, okay, that's probably what I would have expected, right? In terms of central USA being more prone to tornadoes. This is NOAA, National Oceanic and Atmospheric Administration data for about 60 years. Oh, fascinating. Okay, so let's take a look at this layer with shows the power of GIS. I'm going to show the table. The G part of GIS is the map or the 3D scene or the satellite image or the drone image or whatever it happens to be. It's the G part. The I part is this table of data behind the map. So in this case, I've got 65,000-ish tornado records from, let's do a sort, just like in Excel, from 1950 to 2019. Okay, so I've got almost 70 years of tornado data, according to NOAA. Okay, we always have to say, according to this data set, this is the pattern. According to this data set, et cetera. More about that in a minute. But I do have a blog. I know this sounds boring. Joseph's data blog. I can't stand my excitement. The point is, this data blog is all about three things. Where do I find this spatial data that Joseph's going through? How do I know if I can trust it? It's an open platform. Anybody can contribute data to this platform nowadays, folks. You are the data creator, not just a data consumer, which has huge implications, including ethics. So this spatial reserves that I'm putting in the chat box, where can I find data? How do I know if it's any good? And can I trust it? And related societal issues, ethics, copyright, location privacy, etc. What do I mean by location privacy? I've got a fitness app. Do I share that with everyone? My walks, my runs, my cycle rides. And if I did, would it matter? There are certain cases where you need to share your location. Hey, if I want that pizza delivered, right, I'm going to share my exact location, not just I'm in Jersey City somewhere. So there's all kinds of intertwined societal and ethical considerations, especially when you're making maps like this. You've got choices. And with those choices comes responsibility. How are you going to symbolize the data? How are you going to render the data? What projection are you going to use? What classification method are you going to use, et cetera, right? Lots of considerations that affects your end user's perception of that phenomenon. So you have a lot of power at your fingertips. And so I say use it thoughtfully and wisely. So here I've got tornado tracks. Are every one of these tornado tracks the same in terms of data quality? I've got 1950. Think about that. Did we have Doppler radar even back then? No. How do we know that this certain tornado occurred where it did in that year? Interesting. Well, it's probably the kind of thing where, hey, this 1961 tornado in Oklahoma, 26 injuries. Well, it damaged that barn and that business over there in that town. And it was in the local newspaper, and they interviewed one of the local landowners, et cetera. So across this field, and you can see the damage, et cetera. So it's anecdotal accounts, oftentimes pretty accurate. But again, could we say with certainty, if we zoomed into this field and we changed the base map to something like, how about a satellite image? Okay, we changed that to, I don't know, let's say imagery hybrid. And here's this town, Winona, Oklahoma, and we've got this tornado. Do we know that it started in this front yard of this house? Well, probably not. We don't have within a meter or a foot, right? We've got, okay, somewhere in the north part of this town, this tornado touched down. We have mixed with it more modern tornadoes, including some of those big ones that you probably remember in your lifetime and mine that are huge ones, right? Very wide. And that's another discussion point. Another discussion point is, so we've got apples and oranges mixed in the same data set. Also, these aren't straight lines, right? In reality, that's one of the things that makes these things so scary, correct? Is that they're sinuous. We don't know exactly what the behavior is going to be. We don't have that. All we have is the touchdown point and the liftoff point, and then we connected those with a straight line. Another thing that's interesting about this is that you've got a width in here. Okay, well, how accurate is that? Okay, every one of these is symbolized with the same straight line, and it's thin. Maybe we should symbolize them by width, because that indicates a bit of why these things are so dangerous and why we actually care. Remember, what's where, why is it there, and why should we care? And why should we care that we've got a certain pattern here? A lot of these seem to be trending from southwest to northeast. Why is that? So it's anchored to, our study of climatology and meteorology. The point is, we've got a lot of data at our fingertips, and we can do some really in-depth studies, but we also need to be careful about data quality along the way. Interesting. Okay, fascinating. Now, a lot of times we have a lot of data at our fingertips, and we want to be able to filter that data so we can say, hey, on the filtering tool, what if I want to add an expression? Okay, what about this? Ooh, let's change the base map here because this is fascinating. Well, let's just leave it alone in terms of time. If month, ooh, gosh, I've got, look at this. I've got, oh, wow. I've got a lot at my fingertips. There's the April tornadoes. There's the March. There's the January. Interesting. So I could filter these month January. Interesting. And I can see the pattern of January, February, March, April, spreading up to the North Dakota, then ebbing back down to the Gulf Coast by November, December. Fascinating to be able to do this. Oftentimes, as you know, we have too much data. This looks like that those noodles you can get at certain kinds of restaurants. It's like the white noodles that are all mixed up and they're crunchy. That's to me what this looks like. It's hurricane data, and there's so many of them there. I can't really make sense of this. I mean, good grief. This is so dense, I can't even see the base map behind here. So again, if I filter the data and I say, hey, a lot of times what I want to do in a GIS is I want to get to where I can look at patterns, relationships, and trends. So if I filter this data, I could filter it on month. I could filter it on the category, right? Again, with the filter tool. And if you know a little bit about expression building, that's a very powerful thing. So if you learn a little bit about the arcade expression language, which is part of ArcGIS Online and ArcGIS Pro, and I'm going to add an expression here, and I can say, hey, just like we did with the tornadoes, I can say, well, there's the August tornadoes. I've got it by number. So there's the July hurricanes. And then, June, May, not very many. What about April? I've got one in the data set. And then February, January. So what is the max? It looks like, as you probably would suspect, September is the numeric max. So I could also say, well, I really only want to look at category, okay? Replace category is, what do I have for choices there? I've got probably category EF. I've got category 1 through 5 in terms of hurricanes. So I could say, I really want to look at just the big hurricanes. Okay, so I can do that. So filtering, symbolizing, all these are important considerations when you're using a GIS. Another way to do that, of course, is to create a story map or a filtered map like I've got here, which I've just selected the 10 most damaging hurricanes, and I've made this map with, again, some symbology that may or may not work so well. The colors could be adjusted a little bit. But then here's a story map on tropical cyclones and why they matter. So this is another way of conveying the information that I had in my big geo database for maybe constituents, patrons, board of directors, for the general public, et cetera, about why tropical hurricanes matter, and with some maps in there with some charts, some graphs. So the point is, story maps, there's about 2.5 million story maps in existence right now. 2.5 million of a wide variety of quality. The point is, story maps, dashboards, infographics, visualizations are being used to convey the results of business decisions, as I've illustrated earlier, hazards decisions and data, and a whole wide variety of other phenomenon and issues that are critical to us building a more resilient future. So the point is, you've got a lot of data at your fingertips. You've got some good tools. You've got a great community of people in the geospatial world. And I would just encourage you to think about the following. With all those good people and good tools and good models, climate models and other things that we've got at our fingertips, we want to be smart about the way that we use geotechnologies, not just because they exist. We want to choose geotechnologies when it's appropriate to do so. And oftentimes it is appropriate to do so because we're asking the whys of where question, but also being thoughtful about the data, right? Where does it come from? Where can I get it? How do I know if I can trust it, et cetera? So because everybody is a map creator now, not just a map consumer, right? Including you, students, and you, all you faculty. So those are some thoughts about why this all matters and how you can journey forward. How can you journey forward? Well, building your network, as I mentioned at the beginning, taking an ESRI or another MOOC, a massive open online course, free, 6 weeks long, rigorous, fun. There are some lessons that you can use to dig into the hazards or business or anything else that I've talked about. We've got landing pages on using this in business education, using this in data science, using this in geography education, et cetera. So there's no shortage of resources. But being busy people that you are, you want to choose wisely about the resources that you're going to use to build your courses, to do your investigations, to do your research, and for your students to most effectively move forward in your geospatial career. Last word about that career point. I have a Geo Inspirations column. So for example, I've featured various people throughout the world. This is a subset of the column about geo-inspirational women in a wide variety of fields. But the point is, this Geo Inspirations column, some are podcasts and some are text interviews. But browse through here, because I think you'll find that no matter what sector of society, nonprofit, business, government, academia, you go into, you can make a difference, a positive difference with geospatial technologies. But remember, the technologies themselves are not the goal. The goal is, let me page down to this. I'm going to put this whole story map in the chat box. The goal is for you to ask good questions and to be curious about the world and investigate. This tool here is the most important tool of all, not buffering and geocoding and all that other good geotechnology stuff. It's your brain engaged and your passion and energy coming forward. Okay, so keep those things in mind. Questions, comments, issues. Again, I'm going to put this whole story map. I didn't have time to go through the whole thing, but I hope there's some nuggets there that you'll be able to take away going forward. Any questions for me? I want to be respectful of your time.